Good morning, functions. Okay, this was the warm-up that we started with today, so I would like you to go ahead and hit pause, and I'd like you to do this warm-up. Okay, so those are the answers. So when you multiply two functions right here, you're going to end up with, I used a box because it was a binomial times a binomial, so I used a box, and I got 3x cubed minus 2x squared plus 12x minus 8. And again, this is a composition, meaning that I'm going to, I see this hole right here, which means I'm going to fill the other one with that. So this says that I'm going to put g of x inside of h of x, which is what I did. So everywhere I see an x value, I replace it with whatever g of x equals. So I got 3, and h of x was 3x minus 2, so I've got 3 times x squared plus 4 minus 2. I distributed the 3, and I got 3x squared plus 12 minus 2, which simplifies to 3x squared plus 10 after you combine my terms. Okay, so make sure that's something you can do. These were really good examples of a meeting level questions that could be on the test. All right, so now I'd like you to hit pause, and I would like you to do all of this. So I will come back with it finished, but I would like you to do all of it. Okay, so here is the graph. This is what you should have gotten. Hold on. This should say -2, 1. Okay, so I went ahead and graphed them. So yes, they both passed the vertical line test. We've got these plots. This graph would be discrete. Both of them are discrete, meaning that we don't have lines connecting them. So hopefully you didn't connect the lines. But something I want you to notice, let me see if I can get this in black, see, is if I were to draw, so we switch the x and the y. So we're saying essentially y equals x. So if we're saying that, if I draw y equals x, which, okay, you're going to have to forgive me. I'm going to do my best to be straight. So if I draw that line there, go down. Okay, that's as good as it's going to get. What do you notice about these? And a lot of people notice the same thing. They notice that they're kind of the same, right? So like these two kind of look like these two. This one mirrors this one mirrors this one mirrors that one. They're like the same distance from y equals x. So it's like they're reflecting. Notice I use the word mirror. They're reflecting over this line. So when we talk about switching the x and the y, we're going to see a reflection over the line y equals x. So that's something to notice. It's something to check. So if I asked you on a test, I would say, hey, plot these points or plot this equation, and then I would say, plot the inverse. That's what we do when we switch the x and the y, we're finding the inverse. The way to check yourself is to make sure that it's reflected over that y equals x line. Okay, so we are doing inverse functions. These are the different things that we are going to cover. You don't need to write all of this in your notes, but I would put like a header as inverse functions. So we're going to decide whether or not a function is one-to-one, and if it is, we're going to find its inverse. So a one-to-one function, this essentially says that for every x value, or this says no repeated x values, which makes it a function, right? If it needs to be one-to-one, a one-to-one function, it first needs to be a function, so we have no repeated x values, but then we add a caveat of no repeated y values. So no repeated x values and no repeated y values. That means it's one-to-one. So something that I showed students yesterday in class was, if I were to draw this graph right here, really sloppy, and I were to say that this was f of x is equal to x squared, then I would say, well, I'm going to find f of 2. Well, f of 2 would be 4, because 2 squared is 4, but f of -2 is also 4. So all of this, yes, it's a function, right? We've already talked about how it's a function, but it is not one-to-one, and the reason why is -2 and 2 both have the same output. But if I were to say this function right here, and I would call this, I don't know, f of x is equal to x plus 4, then I could find f of 2, and that would be 6, but f of negative 2, that would be, what, 2? So notice that they have a different answer, and also you can see that it's going through both quadrants, right? It's going to go through from negative, and this one does too, but it goes from negative to positive. This one stays all positive up here for the y values, and these ones have negative values and positive x values. So this one, this is a linear function, and linear functions, this is 1 to 1. So that's just an example. I would put that in your notes if you, it probably will help later on, but that's something to think about. Another way to look at functions is this mapping. So something I want you to notice is that there are 1, 2, 3, 4, there are five different, so if I were to draw the domain for this one, I would do 1, 2, 3, 4, 5, right? That's the domain. And then the range would be 6, 7's repeated, so I don't need to write it again, 8, and 9. So if we look at that, we've got five elements in the domain, but only 4 elements in the range. So these aren't the same size, but if we look at one that is 1 to 1, I have 1, 2, 3, 4, so 1, the domain for this one has 4. My curly brackets are actually getting worse. The range is got 5, 6, 7, 8. Oops, comma. So that's my range. But notice that they're the same. There's 4 elements in the domain and 4 elements in the range. So for a function to be 1 to 1, we're going to have all the same amount of elements in the domain that are going to match the range. They're going to be equivalent. They're going to be equal to each other, the amount of them. They may not have, like, this one has 1 and this one has 5, so they're not the same, but they have the same amount. So that was something that we noticed. So I would put this in my notes if I were you. So for this one, what I want you to write is that the inverse of a function f is written f to the negative 1. So here's an example. You don't need to write the rest of this. What you need to write is that if function f of x is equal to x squared plus 2, then the inverse of function x is going to be the square root of x minus 2. So that is something that you're going to have. So last test, I was really lenient on whether or not you used matrix notation. So when we talked about the matrix, I said you needed to do this equal, I don't know, 1, 2, 3. I needed this to be your answer, right? In matrix notation. Some of you, hold on. Some of you only put part of this, the 1, 2, 3 in a matrix, and I accepted that because it was mostly right. You gave me the answer, you put it in a matrix, but you didn't give it to me this whole way. If I ask you to find the inverse and you do not give me this f to the negative 1, that's what it looks like. This actually says the inverse of f, but if you do not give that to me, it is wrong. You must use inverse notation. It is important. I need you to know how to read it, and I need you to know how to write it. It is something that is going to continuously come back up as you go throughout your math, throughout your life. So make sure you get those in. Okay, your first example. I would like you to tell me whether or not this function is 1 to 1, and if it is, find its inverse. So if we look, none of the x's are repeated, plus it tells us it is a function, and none of the y's are repeated. So since none of the x's and none of the y's are repeated, it is a 1 to 1 function, which means I can switch the x and the y. So when I say find the inverse right here, that find the inverse means switch x and y. That's for all forms of inverse. If I ask you with this, like this is a set of points, switch the x and the y. If I give you a table, switch the x and the y. If I give you an equation, switch the x and the y. There's some extra stuff with equation, but the first thing we're going to do, switch the x and the y. So that is something that when you hear inverse, think switch the x and the y. So this one, we've got no repeated x's, so this is a function, but we have this right here, which is repeated to 3, so this is not 1-to-1. But here's something I'd like you to notice. I'm going to find the inverse, because you can still find the inverse of a function. This is a curly bracket, just so you know. All right, so that one would be 3, 0. And then this would be 2, -1. And then we would have 3, 1. Is this inverse of this set of numbers, there we go, is this a function? No. Look, the 3 and the 3 are repeated, and x's can't be repeated. So this is not a function. Not a function. So that's something to think about. So when we're talking about 1-to-1, that means that when we switch the x and the y, the first part's a function and the inverse is a function. So if it is 1-to-1, the function's a function, the inverse is a function, which is a big deal. This one is not 1-to-1. So then the inverse of it is not a function. All right, I would like you to at least put the table in. You don't need to put all of it. These are some pretty quick times here. And apparently we have a cross-country runner on our team that can run around those times. So it's a pretty quick runner. This is 1-to-1 because the distance and the times aren't repeated. And if I were to find the function or the inverse of it, I would literally switch the x and the y, and notice my x's become the time and my y is the distance. Meaning, if I say you run, this particular runner is running 16 minutes, he's going to be about 5 kilometers away. If it were me, I would still be halfway through. I would be at like a 3K. Okay, so if you have any questions, please come and see me, but make sure you got your notes updated. Otherwise, have a great day.